In 1995, astronomers pointed the Hubble Space Telescope at a patch of sky so small it could be covered by a grain of sand held at arm's length. They left it pointed there for 10 days. What came back changed everything. 1,000 galaxies, each one containing hundreds of billions of stars, all crammed into a sliver of darkness so small that nobody thought there was anything there. That image, the Hubble Deep Field, became one of the most important photographs ever taken. Not just in science, in history. It told us, in a single frame, just how impossibly vast and full the universe actually is. This is the entry of the cosmic ledger. And today we're talking about what comes next. Hubble launched in 1990. It has been orbiting Earth for 34 years. In that time, it has helped calculate the age of the universe at 13.8 billion years, confirmed that the expansion of the universe is accelerating, captured the deepest images of space ever taken by human instruments, observed the atmospheres of planets in other solar systems, watched a comet collide with Jupiter in real time. It has fundamentally changed what we know about where we came from, where we are, and where everything is going. And it did all of this through a mirror just 2.4 meters wide, peering at the universe through an opening barely larger than a bathroom door, NASA's Roman Space Telescope has the same size mirror as Hubble, 4 meters, identical. But Roman's camera covers a field of view 100 times wider, not 100 times more powerful in the traditional sense, 100 times wider, all at once. Imagine replacing a drinking straw with a floor-to-ceiling window. That Hubble Deep Field image, the one that took 10 days to capture a grain of sand-sized patch of sky. Roman can capture a field 100 times larger than that in 20 minutes. In a single year of operation, Roman will image more of the sky than Hubble has in over 3 decades. The same amount of observing that took Hubble its entire career, Roman will do in roughly 10 days. So what is Roman actually going to look at? Everything. But there are 4 areas where it will change a science permanently. Dark energy. We know the universe is expanding. We've known this since the late 1990s. But here is the part that keeps physicists awake at night. It isn't just expanding. It's accelerating. Something is pushing galaxies apart faster and faster. We call it dark energy. It makes up roughly 68% of everything in the universe, and we have no idea what it is. Roman will map hundreds of millions of galaxies across cosmic time, tracking how they cluster, how they move, how the expansion of the universe has changed over billions of years. It won't just detect dark energy, it will measure it with a precision we have never had before. Dark matter. 7% of the universe is made of something else we cannot see, touch, or detect directly. We know it exists because of the gravitational effect it has on everything around it. Roman will use a technique called weak gravitational lensing, mapping how light from distant galaxies bends as it passes through invisible concentrations of dark matter. It will produce the most detailed map of dark matter ever created, a map of something we cannot see, built from the shadows it casts on light. Exoplanets. Roman will monitor hundreds of millions of stars simultaneously, watching for the tiny flickers of light that indicate a planet crossing in front of its star. Current estimates suggest Roman could discover more than 100,000 new exoplanets. For context, we have confirmed roughly 5,700 exoplanets total in all of human history. Roman might multiply that number by 20. In a few years, the large-scale structure of the universe. This is the one that excites cosmologists the most and gets talked about the least. The universe isn't random. Galaxies form in filaments, vast cosmic webs of matter stretching hundreds of millions of light years. Between them are voids, empty spaces so large that our entire observable neighborhood fits inside one. Roman will map this structure at a scale and resolution never attempted before. And that map will tell us something fundamental, whether our models of how the universe formed are correct, or whether we have been missing something enormous all along. Roman is named after Nancy Grace Roman, NASA's first chief of astronomy. Appointed in 1959, she was one of the key figures who made the Hubble Space Telescope possible. She fought for it, planned for it, and advocated for it for decades before it ever launched. She died in 2018. She never got to see what Hubble ultimately became. The telescope that will surpass Hubble carries her name. That feels right. Roman is fully assembled. It passed its final testing ahead of schedule. Launch is planned for September 2026. When it reaches its orbit, 1 million miles from Earth, at a gravitational balance point called L2, the same location as the James Webb Space Telescope, it will begin the most comprehensive survey of the universe ever attempted. In the first year alone, it will generate more data about the cosmos than all previous space telescopes combined. We have been looking at the universe through a keyhole for 34 years. In September 2026, the door opens. If Hubble showed us that the universe was full, Roman is going to show us what it's full of. And whatever it finds, whatever dark energy turns out to be, whatever structure it reveals at the edge of the observable universe, whatever worlds it discovers around distant stars, the cosmic ledger will be here. This has been an entry of the cosmic ledger. The ledger stays open.